Good morning, everyone. Now we are beginning with the Big Data Bootcamp, and this is the day one session. And let me help you with certain things. Those who are very new to big data, so I will also help you to how basically you can work with the setup. So that also initially 5 minutes I will take to tell you that how you can work with the setup. You will get all the links and everything. Those who already have got the setup and those who can work with the setup, they can directly go ahead and perform practical. It may happen that you are unable to perform certain things because they may be new or due to some configuration changes that may happen. So what you can do is you can re-refer to this particular video, and we have respective groups where we are connected. You can ask your doubts over there. We will have more practice sessions specific to your queries. So let us basically start. This is the day one, and here basically we are going to learn Apache Hadoop's administration part. That is one thing. And second thing we are going to learn is MapReduce. We will be exploring examples of MapReduce here. So let me help you. So it's 15th March 2023 today, 7:30 a.m. We all are connected on Zoom and certain participants on YouTube Live. We have given you certain guidelines. I'll just quickly repeat it for you all. So if there are certain guidelines which are instructed for this particular session, you need to follow them. This is a part of bootcamp, so you'll be getting a certificate also. For that, you need to get registered and you need to complete the assignment and the given task that will be explained during the session. You need to be patient for technical issues, as we always tell you, because technical issues may come for libraries, for configurations, so that happens. So that is natural. So you need to be very much comfortable for the same because those things may arise and we need to find solution for the same. Make sure that your internet speed is better before joining so that you don't find any kind of issues for the video, audio, or screen sharing, whatever is being shared. Join the session. You guys have already joined the session. That's wonderful. I welcome you all. Test the equipments before you join. So this is the agenda which we are going to cover. That Hadoop administration, we'll see how to work with SDFS, certain SDFS administration commands, MapReduce workflow, and especially with Java, we are going to explore certain data sets and how we can work with MapReduce in Java. So that is basically mapper, reducer, those codes we will be exploring. We have certain tools and equipments. These links will get provided to you. So these are the links which we have. That is VMware Workstation you need to have. So you can download and configure the latest VMware Workstation, or you can download and configure VMware Player as well. So Player is also equally good. So these are the things which you can download and work with. Now, moving ahead, this I will show you also. So practically, let me show you as well. So I have already configured VMware Workstation. So here you can see that once you download and configure VMware Workstation, it looks like this. So this is how it gets opened up. Let me go to the Home tab. So under Tabs, Home tab. So freshly, it looks like this. It may happen that VMware Workstation, you like I have 16 Pro, you might download some other version, right? So based upon the other version, the color, a bit of interface may get changed. So don't worry about it. And that's basically all okay, all good. It doesn't, really matter with the color of the VMware Workstation. Now, here we have an option to create a new virtual machine, which we are not going to do. So we are not going to basically create a new virtual machine. We are just going to open a new virtual machine. And I will suggest you to just install VMware Workstation, or I'm saying, or you can just install VMware Player. So these two things are good enough to basically work with. Two in the sense, out of two, any one you can do. Now, let me go back. Here you have Cloudera Quick Start link also. This machine you have to download. This is Cloudera's machine. Here you can see this is Cloudera Quick Start machine. So this machine you have to download and extract it. So let me show you how you have to do that. Download option, I don't think it's a big challenge. So you can simply right click and you can click on the download and it will start getting download. That is the first thing you have to do. Now, what is the second thing you have to do? Once it is downloaded, then let me show you, you have to extract it. So here you can see that I have already downloaded this particular file. So this was the compressed file I downloaded, Cloudera Quick Start VM. I right clicked on it and using any of the tools like WinRAR, you can extract it. So here we have extract all option and then I clicked on extract and which I already did. And here you can see I have the extracted folder. So this is the extracted folder I have. Now, if I go inside that particular folder, so here I am, and I will click here. So these are the files I can see inside this particular folder. You can see lot many files we have. Here you have to search for the 3 KB file. I will highlight this because if I say that sentence just for once, it may become difficult to remember. So this one is a file, I have highlighted it, and the size is 3 KB. Look at the size, that is 3 KB is the size. So this one you have to double click. This one you have to double click. So I hope this is very much clear now. I have clearly instructed. The option number one is configure VMware workstation or configure VMware player. That is first option. Option two is you need to configure this particular file, that is a zip file. It is Cloudera Quick Start. You have to download it. I have given you the link. And after downloading it, you have to basically extract it and open the 3 KB file. That is what you have to do. Once you open the 3 KB file, then what will happen? Let me show you that. I will show that what exactly happens when you double click this particular file. So it directly gets opened up in the VMware workstation. Or if it is asking you that choose a program to open this file, choose VMware workstation, or second option you have is choose VMware player. So these are the initial instructions you need to follow. Those who are aware of this, who have this machine, you can basically simply power on this machine. So what is the next step? The next step is to power on. Have a look at this particular option. So here we have an option of power on this virtual machine. I will do that. Let me power on this machine. I clicked on power on and it will get started. So this is initial step. And now let us basically have a look at certain docs. So I'm going to my drive and here let's bring upon Hadoop admin commands and benchmarking. Let me introduce you that Hadoop admin commands, benchmarking or handling the HDFS, it is very simple and easy for those people who already know Linux. So therefore, we need to understand the Linux operating system. Here, those who are raising hands, I would request you can simply pass on your queries in the comment section, and I would really help to help you to configure that. This is live session, so probably I will not be able to help you on troubleshooting on your machine. For that, we will have separate sessions which will happen on Zoom again, but they will be separate sessions. So be assured that we will be helping you out there as well. So simply what you can do is you can keep on helping us on chat and you can help us. I will be helping you live wherever possible. And otherwise we will have, okay. Yes. So yeah, so the kind of comments which are being passed, we know that sometimes we have people like this who keep on passing comments which are irrelevant. So try to ignore them as of now. Relevant comments will surely be handled. Okay, so here basically we are working with the SDFS, and let me introduce you with the environment. So my machine here is getting opened up. It is a ready-made machine with multiple tools configured into it. So I will help you that what all tools do we have. So here you can see that we have Apache Hadoop. So that is one particular tool which we have. And the version is 2.x. It is 2.x, and currently we have Hadoop 3.x as well. Then secondly, we have the next thing we have is yeah, for Mac users, you have to basically, yes. So here basically you can see that on Mac we can have VMware Fusion. Okay, so we have VMware Fusion that is basically can be worked upon on okay, Mac. That is something you can do. VMware Fusion you can download, and that can help you. Just search for a free version. Okay, if you have a free version, that is going to help you. Okay, all right. Yes, so I have basically made the chat open. Okay, and I would just request not to pass any kind of comments which are unparliamentary, unethical. Okay. Yes, so because we have volunteers who will work for other volunteers, other participants, they'll be helping them out. So I would really appreciate your, support here in this particular session. Okay, so Hadoop 2.x is there. We have Apache Scoop here. And then we have Apache Plume. We have Apache Spark. Then we have, yes, so Hadoop 2.x, Apache Scoop, Apache Flume, Apache Spark. We also have here MySQL for handling out the structured data. Then we have a tool called as HBase here. We have a data warehousing tool, Hive. We have Apache Pig as a scripting tool. We have Zookeeper configured over here. And we have certain monitoring tools also, monitoring tools. So a lot of tools we have here. And you can see a lot of tools we have here. And these particular tools, if you see, that help us in all of the data engineering part, they help us on all kind of data migrations and all. Okay, so let us do one thing. Okay, let us move ahead and work on certain things now. Okay, so this is the machine which get opened up, and now what we need to do is we need to have our terminal opened up. So let me make it full screen first. So I have made it full screen, and let me help you with terminal. So in this particular machine, you can see that the terminal gets opened up here itself. Here you can see this is terminal. And in this particular terminal, we can work for Linux commands as well as we can work for our SDFS Hadoop commands. So Hadoop does not give any other shell. So normally if you see that if I want to work with MySQL, so I can type MySQL and I can type -u as a user. I can put up with the username. I can type -p for password, and I can put the password, and we can see that I'm getting into the MySQL shell. So I'm getting inside the MySQL shell. But if you see that in case of Hadoop, it doesn't happen that way. Like Hadoop is not giving you any kind of shell like MySQL has given. Similar way, if I want to get into Hive, I'll just type Hive and I will get into the shell of Hive. So you can see that I'll be getting into the shell of Hive. So here we need to understand that we can work with we can simply work with the Linux terminal in order to work with Apache Hadoop as well. Because we need to understand the Hadoop administration and SDFS part first, and then we can easily work with the jobs which we are creating. Therefore, let me help you first with Hadoop administration. As a part of administration, certain UIs you need to explore. And what sort of UIs you need to explore? In this particular machine, you can see that the UIs are given here itself. If you go to Hadoop, and here under Hadoop, if you see, we have SDFS name node. So I'm just highlighting that particular portion again. So this particular tab, if you see, so under this tab, if I click, the first option I get is SDFS name node. I click on SDFS name node and it opens up the page of SDFS name node. Similarly, you can go to the new tab, and once you go to the new tab, you can again click on this particular and you can click on resource manager, yarn resource manager. So once you click on yarn resource manager, it will open up the page for that particular yarn resource manager. So UI is easy and simpler to understand, and therefore we should go to the user interfaces and we should work with them. So here you can see that it says this is started on 14th March 2023, and time is given, and it says that it was compiled in 2017. So this release of Apache Hadoop was actually compiled on 2017, and it is a version that is 2.6.0, and it is written CDH 5.13.0. So CDH 2.6.0 comes from Apache, and CDH 5.13.0 comes from Cloudera, because this is a ready-made machine given by Cloudera to us. Therefore, this version 2.6.0, this version is of Apache Hadoop, and this CDH 5.13.0, it is coming from Cloudera. So if you know that Cloudera and Hortonworks were the initial companies who actually started to give services for Apache Hadoop. So they were giving a lot of services, and then there was a merger and they merged and they became a single company, that is Cloudera. And still they are giving a lot of solutions, managed solutions for big data engineering, for cloud services, big data on cloud, for data science services. They are giving many services. Okay. Now, after that, you can see two things. One is cluster ID and second one is block pool ID. So this cluster ID and block pool ID, if you see and understand, that is something very important. Cluster ID is given by name node so that all the data nodes can identify themselves with the name node. It's very, interesting. For example, let's say you are working in a team, and like it's a military force. So your battalion is here. There's another battalion which is here, and there's one more army unit which is here. And now you need to enter a specific area. And when you are entering this particular area, you need to identify yourself that you are a part of them. So you need to have an ID or a passcode which you can tell them. So cluster ID is exactly like that. If there is some other person who is trying to relate themselves with this particular battalion, so he need to have the ID or the passcode for that particular battalion. And similarly, this third person should have the passcode for that particular battalion. So this is what is a kind of secret, okay, that person should have. So here in this particular web user interface, now there might be a question. You will ask, if it is a secret, then how it is so openly visible to us? Because we have not provided any kind of authentication. We can provide authentication here as well. We can basically provide authentication by, Kerberos is there, LDAP is there. You may note these terms, Kerberos or LDAP. So these are the authentication tools which can provide authentication, and without login, you cannot get into these pages also. So web authentication is really required, and I understand that thing. And for that, we have mechanisms. But the purpose we discussed this particular cluster ID, the purpose is that we need to have the data nodes identifying name nodes. So this cluster ID basically does that. Then secondly, we have block pool ID, block pool ID. This block pool ID is again shared by the name node to the data nodes. This block pool ID is shared by the name node to the data nodes. And the purpose is data nodes create a particular folder. So for example, let's say this is my storage in the Linux, which data node has got. Okay. Now, the block pool ID, which is given by the name node to the data node. So let me write that this is a data node. So we have data node. And just confirm me if you're able to see the diagrams which I'm making at runtime. You can just send me a yes in the comment section, so that I'm assured that you are able to see the diagrams or the live annotations I'm making. Okay, thanks for confirming. Okay, thank you. Okay. So this is the storage which Datanode has got from the Linux system. Now, what Datanode will do? Datanode will create a, so let me copy this. So Datanode will create a folder with the name of this block pool ID. Let me copy this and I will show you that Datanode really creates it. So here there will be a folder of this particular block pool ID. And once the folder is created, then what is going to happen? Once the folder is created, after that, the data node is going to create the subfolders. Like under this, there will be subfolders, and these subfolders will contain the blocks. Okay, the blocks which the client store. So, what is the purpose of this block pool ID? This block pool ID purpose is that the if you see the client sends the data to be stored into data nodes, where the data node will store the data node will store the data into a folder, and that folder will be named as this block pool ID. And let us practically see it. I have shown you diagrammatically here. I will show you practically also. So let me clear the drawings and let us basically go to a terminal. So here we have the terminal. Let me exit from Hive and clear the screen. Let me make it a little more larger so that it is easy for you all to have a look at it. So here, first of all, I need to identify that where exactly is that particular file, that BP file folder, where is it? So I need to identify. So let us have an exploration. So we are just using Linux commands to explore this particular machine. So I'm exploring. So currently I'm in a particular folder, and this folder is /home/Cloudera. I'm in this particular folder. And inside this particular folder, if I see, I have Cloudera manager, downloads, item1.java, music, templates. So these many files I have here. You can see Kerberos. I was talking about the security mechanism. So we have that as well over here. So here, if you see that I want to see where my these um, files and folders are stored for Apache Hadoop or other softwares. So let me go to cd slash. So this is the topmost directory I have. And let's do ls. So here you can see what sort of folders do we have. So all of these are folders as they are in blue color, bin, dev, and all and all. Okay, so these are folders. So normally what happens, logs are being found, log data. Let me write comment. So logs are found in the folder /var log. So inside var, we have a log folder. So here we find logs. And you can see that inside this particular folder, cd space /var/log, we are able to see some log files. Already they are here. And we are also able to see that it has got folders. You can see here, Hadoop folders are there, HDFS, MapReduce, HTTPFS, KMS, MapReduce, Yarn, Solar. So we have other folders as well, for which the logs are being created here only. So if I want to have a look at any log, I can run one particular command. You can make a note of this command, because logs are something in administration job where you may be into support job, you may be into associate level job, you may be a senior administrator. All the times you actually have to look at the logs. Logs are very, very important. So let me show you few logs. Now here we have anaconda.log. So if I want to have a look at the content of that particular log, what I will do is I will use a command tail hyphen 20, and then I will make a name anaconda.log. So what does this command do? So this command basically So here you can see it says permission denied. So first of all, let us resolve this particular issue. So wherever you are typing a command, you can always write sudo, okay, and then you can write that particular command. So if you write basically sudo, what does it means? It means that super user doer. It means super user doer. So this Cloudera user, I'm logged in with Cloudera user. Have a look at the screen on right hand side top. So right hand side top, have a look at the screen. It says Cloudera. So Cloudera is the name of the user. So if you type sudo before the command, it will act as a super user. Otherwise, it will act as a normal user. So there is a difference between a normal user and a super user. Super user has got higher privileges, and a normal user is not having those kind of privileges. So always write sudo and then the command wherever you are facing issues like permission denied, which we got the issue over here. So I hope I have cleared this particular issue or doubt if anybody is having. So we have sudo tail -20 anaconda.log. So here if you see that this tail command brings the data from a file from the end of the file. This tail command brings data from the file from the end of the file. And how much data do we bring? We are bringing 20 records, 20 lines of the data we are bringing. From which file? From anaconda.log. So sudo tail -20 anaconda.log means sudo because the file access should be given. Tail because we want to get the last lines. But how many? 20. So last 20 lines from the file. Anaconda.log is the file name from where we are getting these last 20 lines. So this is what is the command. Now, if I want first 20, so I can change the head command, tail command to head. So head command is going to bring the first 20 lines. So here you can look at the command. So this brings first 20 line. So I make use of tail and head, these commands, to get the records from that particular log file. Let me tell you, I also love to use tail-f command. This I will show you for MySQL. Let me do ls and can you please quickly check where is MySQL D? So here we have MySQL d.log. I will run a command sudo tail and -f and then mysqld.log. So sudo tail -f mysqld.log. This I am typing. Now what does this -f means? I have pressed enter and it is showing some of the records to us. So what does this tail -f does? -f continuously looks into the file for the new data and it brings that new data to us. That is what is the task of -f. So I'm repeating, -f, it brings new data to us and whenever that new data comes into the file. So that is what it does. So can we demonstrate that? Yes, we can. I will go to file, I'll open a new terminal, and in this particular new terminal, I will restart the service of this particular MySQL. So let me check how can we restart the MySQL service. So as soon as I'm restarting the MySQL service, you should put your eyes on this particular area because here you will be able to see that what is happening. Here some new logs will get generated. So let me do this part. So sudo and I'll write service mysqld status I'm typing. So mysqld status, we are getting the status as running. And now I will do stop MySQL, stop, and you can see that it is going to get stopped. Are you able to observe that we have logs getting generated? Yes, we have the logs getting generated. Okay, we have the logs getting generated. Okay, great. So now what we can do further? Now we can start that service again. So here you can see we can start the service again. Okay. So here you can see some more logs are being generated because we started it again. Okay, fine. So this is the live example that how basically logs get generated in real time. So logs always get generated in real time. So we need to capture these logs, gather these logs, and work with them. So when we work with these logs, then we can identify some basic things which are very important, yet basic but very important. So what we can identify? We can identify that what sort of logs are they? So here we can see that some sort of ID or number is given. Then we can see that some timestamp is being given. And after that, we can see it is coming from InnoDB. So InnoDB related log is there. And it says data was not shut down normally. Where we have InnoDB and starting crash recovery. So we need to understand these logs. So one thing is that we can write some programs, and those programs can help us to understand these logs. Or secondly, what we can do is we can work on what? We can work on certain tools, like we have a tool called as Splunk. So Splunk can help us to identify and pick up these records. It will pick up all these IDs. It will pick up all these timestamp. And here, whatever note is written, it will pick up these things, and it will show us in a graphical manner that how basically all these things are, it will show the count that how many InnoDB related logs are generated. So that is how it will give us a count. So log analysis is very, very important. And let me show you another log. So once you're running this particular command, just press Control C or Control Z to break this command, because it will continue to show you the logs from that particular file. Now, let me move ahead. Yeah, Kerberos is being used. So there's a question that is Kerberos is still being used. Yes, if you see LDAP is very basic, Kerberos is still being used. And if you see the reason behind it, the reason is that because we have systems which are running from very long time. So a lot of systems which run from maybe around 20 years, 25 years, it is very difficult to immediately migrate them into a new mechanism. So they keep on following the old and which has been very much utilized, and the processes are being used by the resources. So they keep on using it for longer time, and slowly changes happen. So that is how it actually happens. Okay, all right. InnoDB, it's just telling about the database name, okay, for MySQL. Okay. Now let us move ahead and let us see one more log. Let us go to SDFS now. CD Hadoop SDFS. Let's go inside that. And here, LS, so you can see a lot of logs, right? A lot of logs are there. If I see ls-ltrh, it will show me the latest log also. So this is the latest log. And this is the latest log because when we started up this particular virtual machine, at that particular time, what happened? It started the components of Hadoop also. So here you can see that we have Hadoop SDFS name node. This is also there, which got started. So that is the log we have. Let us see what is there in that particular log. So tail hyphen, I'll start with sudo tail tail hyphen 100. I will bring the 100 lines, and I will put Hadoop SDFS name node quick start cloudera.log. Enter. These are the 100 lines. Now I will say that when you will see these lines, you will say, oh my god, what is written over here, who will read all this? But just get familiar to whatever is being written over here. So try to keep on reading it and try to observe it. That is something you should do. So try to observe, what is this last line? Okay, if I click, this is one record. If I click on this, this is another record, this is another record. So one record basically starts with date and time. You can see date and time, right? So we have date and time here. And then we have some number, which I believe is a part of second or something. Okay. After that, we have info. This info is that what type of log are we looking at? So this is simply info level log. Why? Because when the name node service was getting started, so at that particular point of time, it is just information that it is getting started. Let's say if there was a crash, or if there was great utilization of some resources at that particular point of time, this info would have been warning. So you could have seen warn. Okay, at the time of some errors, this info would have been error. So understand what I'm talking about. I'm talking about how do we do the log analysis. We will analyze the log by looking at these particular words, that whether it is info level log, whether it is a log of, let's say, info level or warning level, or probably fatal or error level. So there are different levels of the logs. We debug level logs are there. So we can enable certain levels, we can disable certain levels. So that is first thing. So now you can create an application where whenever you are getting a log which is of let's say warning or error type, so at that particular point of time, whenever error type log comes in, you should immediately go ahead and trigger an action. The action should be that some support level engineer should get notified, and that person should handle that particular error. So this is what is the purpose of logs. You get aware that what exactly is happening inside the system. Can you quickly send me a yes if you are able to map and understand that how I'm making telling you the application of these particular logs? Okay. And those who are connected on YouTube, or those who want to refer back something, you can basically open up the live link and you can basically quickly rewind back, and you can come back to this particular part. So that is how you can always do and come back. Okay. So once again, as it is live streaming, so we will go in a smooth way. All right. All right. So I have shown you the logs from this system itself. This system itself. You can get logs from any system. We created one application which is called as we created it for our client, and that is Patanjali. We created that application. It was gaining a lot of data, which was transactional data of whatever sales and purchases happened with the help of a Swadeshi Samriddhi card, a loyalty card, customer loyalty card. And every day near about 1 crore transactions we were receiving. And there also, in that software, we created a logging mechanism. Okay, we created. So understand, every software we try to create a logging mechanism, because that is important. This logging mechanism helps to debug later on. Let's say if some user has done some operation, how would you get to know that that particular user has performed that operation? So we created one logging mechanism, and that logging mechanism was making an entry that now this user is logged in, and the operations which are being made, we were writing it into a file, and who is doing that? That user one is doing that. So if you want to debug later on, you can easily get to know that yes, who has done it. Okay. So logs are very important. Any and every software which is being created, a mature software is always having a logging mechanism. Okay. And this is what we can see here. This is Apache Hadoop, very much matured software framework, and it is having logging mechanism. We can see here, right? Let us move ahead. Let us move ahead and try to see for certain others. So here, let's go for Yarn, CD, Hadoop, and Yarn. Let us get inside that. So here you can see node managers log. So ls -ltrh. So here you can see. Yeah. So here you can see this is resource manager's log. Let me show you that. So tail-f yarn resource manager log. So here you can see we have the logs from resource manager. Okay, it also tells that all of the logs are info level. Okay, all of the logs. Now if I basically go to this particular place, okay, what I will do now is I will try to stop it. I will try to stop the resource manager, and you can see that if I stop the resource manager, what is happening? It is going to basically help me with what? It is going to help me with generating more of the logs. Okay, so cd slash I should go to etc init.d, and here let me find the services. Yes, you can see that all the services are here, so I can manage the services from here as well. So I want to have sh sudo. I'll directly do sudo, and I'll utilize Hadoop yarn resource manager status status. So yeah, sudo service I should write. So sudo service service sudo service. So it is running. Okay, so sudo service Hadoop yarn resource manager status. What I'll do is I'll stop it. Stop that. So if I stop that service, then what is going to happen? Yes, so in that particular case, what you can do is you can see that certain more logs have been generated. Okay. Okay, certain more logs have been generated. Here you can see. Okay. And it says shutting down the resource manager at quick start. This is the host name. This is the machine name. It has shut down. Okay. But all these are info level because nothing, nothing, something like warning or that way, nothing happened. But here you can see. So here you can see error level log, error, warning level log, error level log, right? So some service org.apache.hadoop.yarn.server.resource manager, then returning interrupted. So some process got interrupted under resource manager only, and it gave error. Then warning, because these are dependent. Like one service is dependent to other service. So if one service is dependent to some other service, obviously it will get interrupted. So interruption. Okay, and that is error level log. Okay, so first information has come that some abstract liveliness monitor node manager liveliness monitor thread interrupted. Now you got the link here. Resource manager and node manager sends heartbeats to resource manager, and resource manager is managing out the heartbeats and monitoring the node managers. So it says that we had a abstract liveliness monitor. So abstract liveliness monitor. So that monitor actually got what? That monitor got interrupted. So if that monitor got interrupted, then yes, so there was a possibility of getting error. Okay, so that's why we got the error. Okay, now let's move ahead, and here we have warning level again. So it says that yeah, scheduler. Now you can see, so one component. So here you will have to understand that what is happening. So here you can see that in this particular case we have in this particular case, we have one component as abstract liveliness monitor. We have one more component which got hampered, which is fair scheduler. These are the sub components which are running under the yarn framework, where we have resource manager, where we have the application manager. So it is running under them. So that got interrupted, and therefore we have a warning level log. So in this much of detail, I'm telling you because we need to read these logs. I have seen that, the word procrastination. People feel procrastinated to read the logs. So no, just read the logs. Okay. Now you know that, yes, most of the logs have got timestamp, date timestamp. Most of the logs have got their levels. Okay, which level is there? And then we have the log message. Okay. So message was that it is interrupted. and therefore it is exiting. It is interrupted and it's exiting. Okay, here you can see this is AM liveliness monitor, application master liveliness monitor. Okay, it got interrupted. Okay, so this is what is basically we need to see. And then final message was shutting down message. Okay, shutting down resource manager. So all the sub component got closed, and then finally the resource manager also got shut down. So once again, I would like to get a confirmation over here. Are we able to follow? Are we able to understand? We are discussing Hadoop administration, how basically at the backend things are getting run. A quick confirmation on chat. I would like to understand from all of you. Are we all getting what exactly we are being discussing here from a couple of minutes? Okay, great, great. All right, on YouTube as well, I would like to get, if you're getting, please send me a yes. Thanks for your response. Let us move ahead. So this is how basically we try to see the back end that what is exactly happening. Okay, let me try doing one thing. Let me do run the command once again, and let me write the double, you can see this greater than symbol, and let me create a file, and this file can be named as tmp underscore, this is yarn.log, enter. Okay, it says permission denied, no worries. So I will have to write here sudo, 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 enter. Okay, again it says permission denied, fine. So because it's Cloudera user, that's why it is saying this way. So sudo su, enter. So sudo su basically brings me to Hadoop. This particular in Hadoop, I will not Hadoop, in Linux I will get into the super user, and here let me run this command. So if I run this particular command, this command is again useful. Many a times, whatever output you are getting on the terminal, I'm repeating, whatever output you are getting on the terminal, you need to store it into a file. You have to store it into a file. So how can you do that? So you can do that in this particular manner. If I again, I had stopped the resource manager and I will start it again. I'm starting the resource manager once again. So whatever data is being generated, I want that in a particular file. And let me again check the status. So status, it is running. And let me stop this. I have stopped it. And let me do ls. So do we have that file created? So you can see temp yarn has got created. Let me do cat or sudo cat. So let me do sudo cat, and you can see that that particular file has got all the data. So if you want something to get stored, like lot of output we get on the terminal, sometimes you want to save that output. So how can you do that? You can do it like this. Look at this particular command and make a note of it. So whatever command you are initially writing, whatever command you are writing, what you need to do is you have to, so there's a question, why do we need to store? You need to store for further reference. Further, I'm not saying that in this particular case, I'm not saying in this particular log file case, no. There's so many times you are running, let's say Apache Hive, you are running MapReduce, and MapReduce is generating some logs in the front end, and you want to store them. For, let's say, I'm not having access to the root user. Okay, because I have done that access. Therefore, if you see that I was able to, run all the commands. But if I don't have access, to the root user, and I'm getting certain logs in the terminal itself, but I will not be able to access the logs. Okay, then, so I would really like to store them for my reference because I need to debug. I'm working on it. This happens many times. This happens. It will always happen. If you are in a job, you will be working at certain level, let's say 10. So level 9 person will have more access than you. So in that particular case, whatever information you have, you should preserve it so that you, at least whenever you are troubleshooting, you can utilize maximum available information. So I hope this question is also answered. You can basically say yes or no in the chat box. Accordingly, I can extend or I can help you more. Okay, so I was explaining on this part that whatever command you have, so here you have this particular command, you can see, which generates some output. So after that particular command, just type what? You can just type these arrows. Okay, you can just type, okay, like this way. So this is going to help you to write it down into a file, and you have to write the file name. So I have written the file name as tmp underscore yarn.log. So whatever latest log are being generated, we are getting them here. Okay, in this particular file, we are getting it here. Okay, so this is what happens. Now, let me clear all the drawings and let me get back to this place. Okay, so yeah, now let us move ahead and let us try to explore the web URL again. So where is my machine? Here is the machine. And yeah, so we were talking about this BP, block pool ID. Okay, so we were talking about that. Now that block pool ID, I need to search for cd slash, I will go for, let me check here, cd etc, let me go to etc. Inside etc, let me check, do we have ls Hadoop? So yes, we have Hadoop and conf. So let's go to Hadoop, and inside that, let's go to conf. So note this particular path. So etc Hadoop conf, this is the path where I have actually came inside. And here you can see that I have the most important configuration files for Apache Hadoop. Most important configuration files for Apache Hadoop. And the first one is code site.xml. Second one is hdfs site.xml. Third one is mapred site.xml. Fourth one is yarn site.xml. So these are the most important files which we have for Apache Hadoop. Core site.xml, I will open and tell you the purpose of these particular files. So those who tried to install and set up and configure Apache Hadoop, okay, so you must have configured these and you must be aware. If you're not aware, I'm just helping you out with the same. Let me clear the screen drawings and let me open up. So here, if you see, I will be using vim core site.xml, and this much is comment, so we need not to basically bother about it. Let's move ahead, and here you can see. So here we have configuration. So the configurations start with this. Now, who are very new to XML or HTML kind of syntax, let me help you with this also. So HTML is basically a web page designer, right? So we design web page with the help of HTML. But XML, if you see, it is a data carrier. So there is a difference between HTML and XML, right? But the syntax is same. The way they write the tags, it is same. There's no difference in that. That is something we need to understand, that how do they write. So here you can see it starts with these particular brackets, and you write a property name. Like in case of HTML, you start with HTML. But understand, don't get confused. HTML is not data. It is for designing a UI. But XML is data. It carries the data. So the tag is like you start like this and you end HTML. So whatever you start, you need to end it. This is something you need to remember. Whatever you start, you need to end it. And there is complete set of nesting. Nesting means what? Like in this particular case, we have configuration. So configuration and then end the configuration. You need to end it. And then you need to write inside it. Just for readability purpose, we put spaces. If you don't write the space, it is fine. It is fine. There is no problem. But for the readability purpose, we put spaces. So space, and then let's say we want to write some property. It is not compulsory that you have to write this way only. You can define your own tags in XML, not in HTML. HTML has got predefined I will say keywords to make it easy. But XML, no. Yes, both are markup languages. XML carries the differences. XML is carrier of the data. HTML is not treated as carrier of the data. Okay. So if you see that, we can write something. For example, I will think I will not write property. I would like to write let's say something. Let's say utility. Okay. So I'm writing utility utility. So if I start utility, I need to end utility. End utility. This is something you need to remember. Is there something else which comes under utility? So here put double spaces, okay, and put that particular thing over here. Let's say utility name comes over here, and the utility name is, let's say, service service one. So service one is the utility name. So end the name also. So this is how we have to write. Is there any other property which comes? So here level, the level of the utility. So level of the utility is 10. So 10 is the level. Okay. So who is bringing this concept? Who is bringing this concept of level, name, utility? You and I, we are bringing this concept. So XML allows you to bring your own set of property names. So when these people were designing Hadoop, they basically decided, okay, we will write configuration, we will write property, we will write name, we will write value. This is what they decided. And that's why they have written this. I hope this is making sense and you are getting clear about this particular idea. This is how we are using XML to carry the property information. It is carrier. Okay, that is what you should understand for this part of the explanation. Let us move ahead and try to understand on these properties. So if you see that why we have made use of core-side.xml, because we wanted to set that what will be the communication port for our file system. That is the name node, how it is going to help us in the communication. So here is the communication port. This is the host name and this is the communication port 8020. We have set the communication port. Uzi is a software which is a scheduler. So we have set a proxy user for Uzi. And we have set up proxy group for Uzi. Then further moving, we have a proxy user for HTTPFS. HTTP means browser-based file system, which basically means that from here, under utilities, we browse the file system. So this is HTTPFS. Okay. So we are setting the properties related to HDFS and especially not exactly HDFS. We are setting the properties related to name node and data nodes, not related to HDFS, but it's management. It's management. Okay. If I say not related to HDFS means not related to how much will be the block size, how many blocks to be created, where the blocks needs to be stored. No, we're not talking about that. We are actually talking about that what will be the communication port, okay, how, what, like, whether every user will be able to access from the browser, the interfaces. So we are talking about that. Okay, we are talking about that. So here you can see host groups, Hue. Hue is another software, Hue. Okay, so Hue is Hadoop user experience software. So even for that, any user can basically access Hue and Hue can access HDFS. So that level of configuration we are doing here, which are related to especially name node and its management, because name node manages HDFS. So obviously these will be related to HDFS somehow, core side.xml. Now, if I basically go for HDFS side.xml, VIM HDFS side.xml. So here in this particular case, now it specifically talks about HDFS. Okay. Here you can see dfs.replication. It is talking about the replicas. So how many replicas? 1 replicas. Why? Because we have single machine. This is the only machine which we have, single machine. So it talks about dfs.replication. Then safe mode extension, it says 0. Okay. Another good thing is that you can always write some comments. Here you can see, or you can always write some description. So here in these properties, description is not given, but you can always write description. Okay. So immediately exit safe mode as soon as one data node checks in. On a multi-node cluster, these configurations must be removed. Okay, so here it is given as a node that these configurations should be removed. Why? Because we are working on a single machine, one node machine. So single machine or one node machine is meant for practice purpose. Okay, single machine or one node machine is not meant for it is not a cluster. It's a one machine. Cluster means more than one, two or more machines. That is a cluster, right? So here you can see that dfs.permissions.enabled, so that has been made false. dfs.permissions has been made false. dfs.safemode.min.data nodes. So for safe, how many minimum data nodes should be there? One data node should be there. Web HDFS has been made true, like from web, whether we will be able to access HDFS or not, it has been made true. Okay, so whatever is related to HDFS that has been given here. Here you can see the folders, var lib Hadoop HDFS name nodes folder. So I wanted this particular folder, okay, where I can show you the block pool ID. This folder I want. So here you can see that every user will store its data separately. You can see that here it is dynamic component $user. Okay, dynamic. So dynamically, now I am using Cloudera user. So I'll be able to explore the data which is stored by data nodes with the help of the instructions given by the name node, where in the DFS/data directory, but that DFS will be a separate DFS for Cloudera. And let me show you that. This is what I wanted to show. So here we have another terminal, and in this particular terminal, let me show you. So clear the screen, cd and slash var lib. I'm checking the path from here. You can see I'm checking the path from here. This one I'm checking. Let us go back. So lib, and after that we have Hadoop -SDFS, then cache, and then username. So SDFS, you can see. Okay, SDFS, then DFS, then data. So here let us go. Here you can see we have data, we have name secondary. So cd data, we'll go to data. Permission denied. Okay, so we will go to sudo. Okay, sudo. Now you can see permission denied, security purpose. Why? Because that data folder is for Hadoop's data, SDFS data. So how can you get direct access to it? You should not be able to get direct access. Okay, but sudo is Hadoop's user. So sudo cd data. Okay, so it doesn't work this way. So sudo su. We'll go for sudo su. Now cd data. Now you'll get entry. So now you can see the user has been changed. So here you can see this is root @quickstart, and initially it was Cloudera @quickstart. The user has been changed, right? So now we are able to get into it. Now do ls. So here you can see we have a folder current. Still we will have certain more folders. Now let's go to current. Inside current we have a folder called as block pool ID. This is what I wanted to show you. Look at this. Now match this block pool ID. Okay, have a note of this, 10286, right? At the end, 10286. Do we have the same block pool ID here, 10286? Yes or no? Right? So this is what? Okay. Right? Yeah. So this is what we need to understand, administration part. There's so many job roles in administration also. Cloudera itself hires at a very wonderful package, very good package. If you have a little experience, maybe a year's experience, Cloudera hires you. So there are many questions that how should we target for the job? I will say you should target for a job. The first job should be of your domain. I would not recommend that you should only go for salaries. I'll say go for a domain. In the second year, go for domain plus a good package. Okay, so if you're facing challenge to get entry into a job, just look for the domain. And in the second go, which can come, the best case could be within 6 months. But after 1 year, you get so many opportunities, so many opportunities. Okay. So then get into that. Yes. So this is data engineering administration part. So this is the block pool ID where data nodes store the data. Let us go. We are exploring the back end, right? Not from the front end. So let us go into that. CD block pool ID, enter. Here you can see again current scanner TMP. Let us go to current. Inside current, again you can see we have a version file, version. Okay. I'm always repeating. If certain things go a little fast, you can always rewind, and then you can look back at that particular thing. We have a version file over here. Now let me open this version file. Vim ver version. Okay. Here also the block pool ID is mentioned. So whenever, sometimes what happens, name node crashes, name node gets crashed, and we try to restart that name node. It doesn't gets up. What to do? We need to set up a new name node. If you are setting up a new name node, then this is one of the configuration files where you'll have to come and update the block pool ID. You'll have to update. There are two cases. Either you'll have to go to name node and update the block pool ID there, or you'll have to change the block pool ID at all the places. Okay. Vice versa is simpler. A new name node, copy the block pool ID from here and give the block pool ID to name node. Even name node has got such a file where you can mention the block pool ID, because if you create a new name node, it may happen that it generates, if there is some issue in the steps, it may happen that it generates a different block pool ID. So if name node is having different block pool ID, your data node is having different block pool ID, they won't be able to communicate. They won't be able to. So you can get that block pool ID from here, and you can configure the name node. Again, administration part. Okay, troubleshoot and make things correct. Let me come out of this particular file. Now I will go to finalized folder. Okay, and let me do PWD for you. So let me make it full screen, and yeah, so here you can see PWD. Yeah. So where we have traveled so far, right? Var, lib, Hadoop, cache, SDFS. So far we have traveled till finalized. Now let me do ls. Here you see one folder. This is subdirectory 0. This subdirectory 0, okay, will also have, so here you can see lot of subdirectories. So the subdirectory will also have subdirectory 0, 1, 2, 3, and you will see that, okay, why? Because, it's a tree structure. Subdirectory 0 will have subdirectory 0, 1, 2, 3, 4. So normally, initially it was following. For example, let's say 64 is the block size. So we had 64 such directories, but here we don't have that way. Here, if you see that it is maximum, I can see 45 here. Now let me go to another subdirectory 0. And here you can see we have blocks. These are the blocks. Okay. Block and its meta. Block and its meta. Meta means meta information. Let me open one block. If it was a text file, we'll be able to read it. If it was not a text file, we won't be able to read it. So this is one block. Let me just read that particular block. So tail, and let me do cat for it. Cat, and that is the block. So you can see it is not a text file, but somehow we are able to read it. Some wildcard symbols or special symbols are there, but we are able to read it. Okay. JSON, IMPL, properties. So something is readable. So these are the blocks which are getting stored at the backend. Okay. And how do we read and write these blocks? By using SDFS commands. SDFS, DFS, -ls, SDFS, DFS, -put. So these are the commands we use to manage these particular blocks. Okay. Fine. So let's make it clear and CD enter. Let's come out of that directory. So normally we should not get into such directories until and unless it is really, really important. But I would recommend you open up your machine, you get into that, you do whatever you want to do, explore. Okay, if something goes wrong, that's fine. That is good. You learn something. So for you, it is the recommendation. In a production environment, I don't recommend that. Okay. Okay, quick responses. Are we good till this point? Quick responses from everyone. Are we all good till this particular point? Okay, on YouTube as well as on Zoom. Quick responses I would like to get. Okay, great, great. Nice. Okay, let's move ahead and now try to explore SDFS in this particular environment. Okay, let us try to explore SDFS in this particular environment. So under utilities, if you want to check the logs, you can directly click here and you can, click and see the logs here also. I have taken you directly to the where log and that particular log file. Okay, but you can take it from here also, quick access. Okay, because we really don't have access to it. I actually logged in into root user, then I was able to take you into those folders and show you. But if you don't have access, then directly have a look at the logs from this particular place, right? That is the mechanism we have been given. Under utilities, the second thing we have is browse the file system. Click on browse the file system. You will see this is what we have is SDFS. With the help of browser we are able to get. Okay. So now whatever we create, let me go to the terminal and let me create SDFS DFS hyphen mkdir slash, and it's a happy dir. So I'm creating a happy directory. Okay, so it will get created. Now here, if I basically try to refresh, you will see happy dir has got created. You can see this is created. Okay, and how would you get to know that it's a directory? Because once you look at the initial permissions, you will see D at the beginning. D at the beginning means it's a directory. If you see something where D is not there, it is not a directory. So here you can see it is a dash. So if it is a dash, it is not a directory, it is a file. Okay, this is how you can identify. So happy dir is created. Okay, so now let me show you. So here we have mechanism to write SDFS commands like SDFS, DFS, mkdir. Let me show you one more thing. SDFS, DFS, ADMIN, admin hyphen report report. So this is SDFS, DFS admin command. It will bring the report. So the report says total configured capacity is 54.51 GB. This is the total configured capacity we have. Okay, total configured capacity. Then present capacity is 43.34 GB. This is the present capacity we have. Okay. And it then tells everything. DFS remaining, DFS used, blocks with corrupt replicas, missing blocks, blocks with replication factor 1. Now, it tells that this is the overall details of the cluster. If you have 10 nodes, then after this line, it will tell about those 10 nodes, but I have only one. So it says live data node 1. Okay, what is the command? SDFS DFS admin hyphen report. This is the command. Okay, so it tells us about, here you can see only one node is there, and this is the live node, and that node contributes 54, the whole of that. So if we have multiple nodes, it will tell us that this node contributes 20 GB, this contributes 20 GB, this contributes 15 GB. It will tell us that how much is the contribution of that particular node. Okay, fine. So let us go here and let us go to benchmarking. But looking into blocks, will it make tampering in consumers' data, or we are just looking into logs? So we were first looking into logs, and then we went into actual data. And you have rightly said, looking into blocks is actually tampering into customers' data, and we should never do it. Okay, so we should not do it. Fine. I'll tell you one example before we are moving ahead. So like we take services from GoDaddy, we take services from for example, from Hosting Raja, Big Rocks for website hosting. Okay, a lot of website hosting we take from them. Whenever that particular server, sometimes we take a shared server, we take a dedicated server also. So whenever something happens with that particular server, what do? We don't have complete access because it's like a application or a software as a service. They or at the max platform as a service they give. Platform also we don't take many times. Platform basically it becomes a VPS, virtual private server. Then we have a control. Then at that particular time we authenticate to them to access our data. We authenticate. For that we get a OTP and then we authenticate. So Prajwal, yes, very valid question. That sometimes we need to do it, but with the permission of the customer. Okay, so we get an OTP, we need to send our authentication, other things, emails and all other IDs. Then they are able to get into that particular directory, the customer care executives or the support executives. Then only they are able to. Okay, fine. So let us basically try to go for benchmarking. For benchmarking purpose, I will require certain libraries, jar files of Hadoop. So let's see that. Okay. Now, benchmarking is basically a process where, let's say, I want to climb a mountain. So how can I say that I have covered 1 kilometer, that is height. So how can I say that I have covered 1 kilometer height? So everyone in the chat box can answer to this particular question, that how can I say that I have covered 1 kilometer and that too vertically? Okay, not horizontally, vertically 1 kilometer I have covered. How can I say that? Quick responses. Okay. And some person who is climbing from this side also says that I have climbed 1 kilometer. Okay, vertically. If you see the levels, so this level is already higher, this level is lower. The surface, the ground here is, and the ground here is having some difference. If you see that, there is a difference, and probably this difference itself is of 1 kilometer. Okay, so understand. Exactly, comparing to benchmark we can measure. So if you see that all the cities have got a benchmark. Okay, all the cities have got a benchmark. There will be a building, and there will be some physical structure. People from civil engineering or people from engineering background, those who had a subjects of civil engineering in the first year, must understand this. There is a benchmark. Even mechanical, electronics, every scientific process has got a benchmark. So there will be a benchmark somewhere in the city that is considered to be 0. And from that benchmark, if you are moving upside or if you're moving downside, we will consider it as positive distance, and we'll consider this as a negative distance. This is how it happens. Okay, this is what it happens actually. So let us move ahead now. Let me clear the drawings. So here we will have benchmarking process, and in this particular benchmarking process, we will try to check the throughput of our cluster. So there are different benchmarks, and these different benchmarks, they start with the test DFSIO, TerraSort, NN bench, MR bench. So multiple benchmarks. Libraries are present. Libraries means they are jar files. We just need to utilize those jar files. We just need to utilize them. Okay. So here, initially what I need to do is, I need to create a directory named as benchmark, and then I need to, then I need to create and load the files. I need to create and load the files into this particular benchmark. And for that, I have a command, Hadoop jar and just make use of the jars and just mention that I am writing, loading the files. How many files? 10 files. What will be the size? 10 MB. So 3 parameters. Write operation, number of files, and then we have file size. These things we have mentioned. Okay. I would like to get a confirmation. Benchmark thing is something new. Are you getting? If you have any kind of confusion or something, please write it down in the chat so that I can make you understand. So benchmarking in Apache Hadoop, you can write yes if you don't have any confusion. You are able to understand. You can simply write no if you have any confusion. I will repeat and make you understand because this is something new for those who have never done it. So benchmarking is a process. Okay, I will explain. Benchmarking is a process where the Hadoop's file system will get tested for that how quickly it can load the data, how quickly it can read or download the data. So this is a test we are doing for our Hadoop's file system. So this part must be clear for everyone. Our Hadoop's file system, okay, so this is what we are checking. A question, who sets it? We test it and we set it at the beginning whenever we are creating or setting up the cluster and we have configured the whole cluster. So at that particular point of time, we run such programs or such codes which test the SDFS output or throughput, and we take those readings and we consider those readings as the benchmark. So who does it? The Hadoop administrator, big data administrator. So that person does it. Okay. So whatever readings we will get now, that will become our benchmark. In future, the cluster should never perform below the benchmark. That is what we need to ensure. So I hope now conceptually you get what exactly is the purpose of doing benchmarking, especially in this particular case where we are doing it. Now you can say yes, and again you can ask questions if you have any. Now let us move ahead. So I will be utilizing this particular command to create some files and load them into benchmarks directory, and then I will be running another command with read option. So here you can see with the read option I'll be running. Okay, so fine. So just to make it very simple, I'll take these commands with me. So I'm taking these commands and let's copy it and take them to this system. So let us take a G editor and put them over here. Yeah, so these are the commands for our reference purpose. Okay, no worries. Okay, so let us do this benchmarking part. So clear the screen. Let me make it more a little larger. First of all, I have to create. Step one is to create a folder benchmark /benchmark. So sdfs dfs -ls/ let us have a look whether we have that folder or not. So we already have this particular folder. So I will delete it first. sdfs dfs -rmr/benchmarks benchmark. So let us delete that particular folder. It is deleted. Now I will create it. So clear the screen and let's have sdfs dfs -mkdir and /benchmarks benchmarks. So always remember that in such experiments, we need to take care of the directory name and all, because the programs basically would try to identify benchmarks as benchmarks only. It cannot identify benchmarks as benchmark without s. Okay, so we need to keep it same. So that folder has been created, benchmarks, and now let us basically run this particular piece of code, Hadoop jar userlib Hadoop MapReduce. Okay, so this Hadoop test.jar file we should get. So first, let me identify that. So ls we will do and we start with user lib. So slash user lib and then user lib Hadoop. And inside Hadoop, we have MapReduce. So Hadoop 0.20 MapReduce. And inside that, we have this particular, so Hadoop test. So Hadoop test. So you can see that here we have Hadoop test this one, and we have Hadoop test MR1. So two I'm able to see. Okay, so two files I'm able to see over here. Okay. And we have one more lib over here. Let me check that lib. It has so many libraries. Okay. And it has got fair scheduler. So here only I'll have to go. So Hadoop test. So as of now, I will check, because the jar file name in the document, it is just Hadoop test. And here we have two. One is this one, another is this one. Okay. So I'll first utilize this one, MR1. I'll try to do with that one. Okay. So mr1.jar, this one I'll be using, and rest of the command I'll write. So Hadoop jar, and then we have given the jar name. So Hadoop jar name. We have to give a class name. So if this particular file is having that class, then yes, successfully our job will run. So let me write that. So it is test dfsio, test dfsio. After that, hyphen right. So let me just take these things and put it over them there. Enter. So now let me check if that jar is correct, then it will be able to perform. So it has basically created a job. Let us quickly go to browse, and let us go back to slash and benchmarks. Is it creating some directories? You can see it has created a directory, IO control, and so many directories it is creating. Are you able to observe this? We created an empty folder, and in that empty folder we have test dfsio, IO control, and so many files. It is creating so many files, 0 to 10 files it has created. So quick confirmation, are you able to follow me that these are the files it has created just now? Are you able to follow me, right? A quick yes, no. Okay, thank you. Thanks a lot. Okay. So we are able to perform this benchmark, and let us see. Let us go to the terminal. It is still performing that job. Now, if you go to the browser, and inside the browser, if you are trying to check on the all applications part, here also you will see one MapReduce job is running in all applications part. So administration job is all about this. Okay. Administration job is all about this. Let me refresh this, and let us see what sort of operation is being run. So here it says cluster metrics, 0 submitted apps, 0 pending apps, cluster node metrics, active node 1. Okay. Now I'm just waiting for it to get refreshed so that we can see our job over here. So it's a bit slow, a bit slow. So we'll have to wait for that much amount of time. Okay, fine. Still loading, no worries. So we should be able to see submitted applications over here. We should be able to see a URL where we can click and see the update. So all that thing is possible here. So it's taking more time. So no worries. Okay, so what we will do is let that job run, and let's go to benchmarks and see what is the size of the files it is creating. So under test dfsio, we have IO control. Yeah, so here you can see it has created IO data, it has created IO write. So it is doing some operation. This is what you need to observe. This is what you need to observe. Okay, IO data, I'm clicking on that. So here you can see block size is 128 MB, but because we have given 10 MB size, okay, -nr files 10, file size 10. So you can see, although the block size is 128 MB, but here you can see the file size is 10 MB because we mentioned that. Okay, so let it get progressed. Now, here you can see map is 0%, reduces 0. Map is 13, reduces 0. So MapReduce are two stages where basically you can see map is 0, then map increases, and in between, you can see in between, reduce also increases. So here you can see when map was 90%, reduce increased to 23%, right? Reduce increased to 23%. So it means that whenever map phase is getting executed, reduce phase doesn't wait for the map phase to get completed. As soon as reduce phase finds enough of the outputs which can be collected by the reduce phase, it starts doing that. And therefore, when map phase was 90%, reduce phase was 23%. Map phase got 100%, reduce phase 23%, then map phase 100 and reduce phase 100. This is what we should understand, right? This is what happened. Now moving ahead, it is giving us file system counters. I believe some people will think, oh, so many numbers, so many things. Okay, but yes, you can, revisit. You'll be able to easily understand, and you would actually love with these numbers. Okay, so here number of bytes read, so 844 bytes read, number of bytes written, so these many number of bytes written, read operations. Okay, so it gives all the counters. Whenever we are troubleshooting, whenever we are debugging, all these things actually help us. So this you need to remember, all these things actually help us whenever we are debugging or whenever we are actually troubleshooting. This we need to know. Here you can see killed map task. So initially, some tasks were failed. So it says yes. So 2 map tasks were failed. Launched 11 map tasks launched. Reduce only 1 reduce task launched. Okay. So you are also getting that how many resources are being utilized. Your processor processing slots. If 2 map tasks are being launched, that means 2 slots are being utilized. So here you are getting, okay, that 2 slots are being utilized. Okay, so that information also you are getting. Total time spent by all maps in occupied slots. So this is in milliseconds. This is the total time. Total time spent by all reduces in occupied slots. This is in again milliseconds. This much is the total time. Okay, so these are the metrics. Then here, here you can see this is file system counters. Then job counters. Job means map reduce these tasks. And now MapReduce frameworks, map input records 10. Why? Because we had how many files? 10 files. One file was one input. Normally, one file is one input only. No. Normally, when we do word count or something, then it opens up the file and it reads the one line, one record as one record. So here in this case, there is a difference. The whole file was one record here. So we had told that 10 files to create, it created 10 files and one file was one record. Output records 50. Okay, it gave 50. Output bytes 378. Output materialized bytes, so actually which is being stored 898 into some file. Input split bytes, this is the input split bytes, okay, in byte size. So here basically then reduce phase, shuffling. Input groups, 5 groups were created. Shuffling with 898 shuffle bytes were there. Input records were 50. Now, whatever number of records are output from map, logically that will be the input to the reduce. So 50. Total output records 5. Okay, so 5 some parameters it must have given as output. Spilled records 100. Shuffled maps 10. So these are the MapReduce framework counters which we have got. And then shuffle errors, file input format counters, file output format counters. So even these reports are being kept as these are useful, this is useful data. Now the final benchmark we have is here. This is the benchmark. Okay. So this is test DFS IO, that is testing the distributed file system input output operation, and the operation is right. Okay. Now date and time is given, number of files 10, number of megabytes 100, throughput MB per second is 1.65, rate of I operation is 1.92, and then we have total execution, total standard deviation 0.81, because 10 times it loaded the file. So 10 times how much deviation happened from one file to other to the third one to the fourth one. That is what is deviation while loading. And test execution time in second is 209. So this is the benchmark for write operation. The same operation can be done. The only thing is this write can be read, R-E-A-D, read. Okay, same operation. So here you can see we can have instead of write, we can have read, number of files 10, file size 10. Okay, so let me run for read. This is the benchmark. Okay, let me quickly copy this. Okay, Control Shift C, I've copied this and I'm putting it over here. This is the benchmark for write operation. Okay, and now we will get the benchmark for read operation. Again, it is running a job. Let us go to the browser. It was a bit slow that time. So here you can see active nodes, and this particular job was being running at that particular time, and finish time, state running. So it is showing the old status. By looking at this, I will say never ever completely rely on the UI. Sometimes UI gets information little late. It may be the client side problem. Client side loading speed may be a problem, but it happens. It says it's running, but our job is finished, right? So let me refresh this. So once refreshed, I'm expecting it to bring the state to 0. And secondly, firstly, we get the output on the terminal. After that, only it gets updated anywhere else. Okay, fine. So it will get refreshed and it will be bringing out the second job entry over here. Okay, that is also it will bring out. Let us go back. Okay, so yes. So I hope this benchmarking process is also clear. I'm repeating. First, we are creating dummy data and we are generating it and we are performing write operation. And for write operation, we are finding the rate and throughput. Secondly, we are doing the same activity for read operation. And third, we can do with somebody that is, we can clean out all the data, because this is not a useful data, right? We can clean out. That is something, the third operation we can do. So this is what is my benchmark for downloading, okay, reading the data. So let me bring it here. Okay, so these are the two data which we have. Execution time, second one took 93 seconds, first one took 209, because first one had to create also and then load it, so it was taking more time. Standard deviation is high here, 46, and above standard deviation is 0.81, which is very nearly low. Okay, now again a quick confirmation from everyone. Now, okay, someone is asking here, does it get dead because of some system failure or natural disaster? Are there some alternative way to keep backup or keep it safe? You have not mentioned for like what you are asking, and probably you are asking for name node. So yes, the yarn architecture, the Hadoop 2 architecture actually provides you a mechanism of bringing up more than one name nodes, and the other name nodes, like the second one, or if you have configured 3 looking at the architecture, current architecture. So if you have 3 name nodes and 2 are always just sitting at the back end, just to see that whenever your first name node is getting down, it will come up and it will start to act as a name node. Then basically that is a solution. So yes, it gets down with some physical damage permanently. Otherwise, the issues are resolved within few minutes. Okay, but if some physical damage also happens, in that case also we have a concept called as standby name node, and which basically gets activated and which works well. Okay, standby one. Okay. So this one was all about the benchmark of this particular system. It also ran what? It also ran the MapReduce. Okay, we were able to see that it also did run the MapReduce. Fine. So I think enough of information we have now, and I'm open for quick question and answer rounds. You all can send any kind of questions related to Hadoop administration, and I'll be happy to answer. Okay. We have done certain things here. I can show you certain more things you can send. Meanwhile, you are sending your questions. I'm just taking you here, and here you can see that we have the 2 jobs entries here which we had run. And let's go back to SDFS part. So here we have data nodes tab. We'll be able to see the number of data nodes which we have. So only one data node we have here, and all the information is about that. Then you can go and check for the failures. When data node volume failures are occurring, there are no reported failures. Snapshot is all about name node, and here basically it is not bringing up that particular directory here. It basically brings up the directory where the name node keeps the snapshot. Startup progress, it gives us the information that when the name node was getting started, it gives the information about that. So here you can see whenever we will start the name node, it will bring those particular log pieces here. This is again coming from logs only. Utilities we explored, it has got browse the file system and logs, these 2 things. Let me come back to overview, and I'm happy to listen to the questions. Okay. One question is, Cloudera need installation of Hadoop? The answer is no. Cloudera already has got Hadoop, and let me show you certain things. It has got Hadoop, and that's why we are able to work here with Hadoop. It has got HBase shell. If I type, you can see I can get into HBase shell. It has got Hive. Let me show you that also. If I type Hive, I will get into Hive. So here you can see I'm getting into HBase shell. Here, if I just type Hive, I'm getting into Hive shell. And then if you see that, if we move ahead and if we see that what else can we go ahead with. So let me quit from here, and Q and enter. Sorry, exit. For this also it's exit. Yeah, let me exit from here. Yeah. So Apache Pig, if you want to get into, you can type Pig and you can get into Pig. So this machine has got so many tools which you will get excited to work with. So I really feel that yes, explore this machine, and it'll be exciting and it'll be useful. Any other question do we have? Let me check on. Okay. Yes. So let me check on the YouTube as well. So I can see that there are no questions. All right. So very important things. So first of all, if you want to get the certificate of the bootcamp, what you need to do is, the first thing you need to do is to register for the bootcamp. And this video is available live on YouTube. You will get all the details on YouTube. Secondly, for your quick reference, I'm sending you all the details here in the chat box as well, so that you can get all the details readily over here. Here we will have an assignment. So you will have to work on the assignment. So I'll be sending you the assignment link as well, and I'll be helping you with attendance link as well. So note down the attendance code. The attendance code is HAD110. So HAD110, this is the attendance code I'm sending you. Let me send it over here. Yes. So let me send the links with you. So first of all, I'm sending you the link of quiz, and the quiz link is posted here. $130 MB, 128 MB, exactly. Okay, good. Okay, there's a question. Okay, if you have an input So I'm sending, meanwhile, I'm sending the quiz link also. I'll answer the question, don't worry. Yeah, so this is the quiz link. Every day quiz winners are being announced. So you can quickly fill up the quiz. It's all first come, first serve basis. A lot of competitions are there. You can check on the YouTube videos, the social media channels which we have. You will always get information about it. Okay. So yeah, now the question is, if you have input file 350, how many input splits? Yeah, so the answer is very much correct. 350 divided by 128, that is what is the output. Okay, let me send you the attendance link now. The second link I'm sending is attendance link. And yeah, so here is the attendance link. And secondly, we have assignment. What we have done here, we did benchmarking actually, and we explored a lot of things. So benchmarking is the uh, assignment for today, and submission link I'm sending, the task submission link. You have to upload it properly on the social media platforms, and you have to send us the links over here. That is a submission link. And those who are actively working on the tasks and updating it on social media and spreading the awareness about these activities. So based upon your task completions and the information you are sharing with us, again we will have certain exciting prizes. So today is 15th. Today evening we will announce that what all prizes we will be giving. So remain excited for that. So I believe I have sent you quiz link, I have sent you attendance link, and the attendance HAD110 is the basically code for the attendance link. And I have told you what is the assignment also. Assignment is same benchmarking operation. Thank you very much for joining in. We will have the MapReduce part in the part 2 of this particular big data bootcamp. You can try to find out the other boot camps, join our WhatsApp group so that you can remain lively updated, and you can take part. Instead of everything, learning is something which is best which can be done. So I wish you the best. Thank you very much.